All right, last time we talked about different ways to iterate through a binary tree. We talked about pre-order, in-order, and post-order. One thing, when we visited the node, all we talked about was actually just printing it. What's very common to do for these data structures is you give a function and you want to run this function or something on every piece of code. One way to accomplish this inside of C is to simply pass a pointer to the function that you wish to execute. So if you wish to visit everything, doing whatever it is you want, we could write a generic traversal function. Now, there are other ways to do this. The C++ way is to actually make a functor class where you give it a function, the class has one function, and then it calls that function every visiting node. The C way is to use function pointers. We're going to learn the C way of doing it, which is to have a function pointer for it. So, pass a function as a parameter to the traversal function. Remember how I said you could create a pointer to anything that's pointable? Well, since your code resides in memory, that means you can create a pointer to your code because it's in memory. So you can point to functions. That is completely legal. And hey, look, here we have some examples of how to do function pointers. Actually, that is passing a function to a function. So let's go over here and do a couple of examples because this can be somewhat confusing at first. Let's see, source unit.cpp. Let's actually, we don't even need to do that. We'll do it in main because this doesn't really require testing since I'm showing or displaying a feature of the language. All right, so let's create a simple one called void print, giving an integer value without the u, and in here I'm just going to print out val with a new line at the end. And I'll do print negative, so it prints the negative version of it. I don't know if I'm allowed to do that, but we'll find out. Okay, so I could just do print neg 5, and that should print the negative value. Let's go make sure this is all working. And it's called simple, so we'll make and run simple. Okay. Now, that's great. What else can we do? Well, I'm going to call a function and I'm going to give it the amazing, well, I'm not going to call it do it. I almost did that. I'm going to call it run function, which is first passed, and I forget the syntax sometimes. So it's a void visit, or I'll call it func for function, which is passed another integer, and then int val. Func is a pointer to a function. So what I can do is I can go, because I need to dereference the function and then pass value. All right, if I type that all correctly, which sometimes I don't, I can do this. And let's see if I did. Oh, I did it correctly. So I have one function, run function. It calls, I pass it a function called print negative. And one thing I didn't do that C does for you nowadays is I didn't create the pointer to it. So there we go. Pointer to the function. Because remember, print neg is actually up here, negative. And then I pass it as a function to a different function so that it can run it later. Why is this useful? Well, now for your lab, you're going to have one function that takes one of these and then runs it on every single piece of data while going through the binary search tree in order. So instead of having to return a string, it just runs this function, and that way I can get the values in a different way by just providing whatever function I want. Obviously over here we could have done something else, like so print negative, we could do print square. I'm just going to call it SQ. I don't know how that happened, but let's try it again. Print negative, print square, and we forgot to do the regular print one as well. So, see how many of y'all have been paying attention? What is the output of this program?
Negative 5.25.
There we go. Yes, this function is very simple, but hopefully you can see how this is going to be extended in your lab by actually iterating through the entire binary search tree and calling whatever function I pass to it. Notice that in order to call the function, I have to dereference right here the pointer to it. It is very important that you put your parentheses around the function, the dereference of the function. This has to do with the precedence inside of C. It may not be able to parse it if you do it otherwise, but if you do it in this syntax, it should be good to go. Okay. All right, how was this? A lot of times students get very confused by this.
So to recall the function, you don't need the parameters like for the end.
Oh, when you declare it inside another function?
Yeah.
So you don't have to call the parameters, you just have to say what the parameters are. Notice I had an integer. If I had a function that took 2 ints, you'd have to put right there int, comma, int. Okay. But you don't have to name what they are. Because that, you actually don't need to do that inside your header file either. The only time you need to actually name them is when you go to implement the function.
Okay.
So, good catch, good catch. Notice that I did have to point out what it returned, which in this case was a void, so it doesn't return anything. Any other questions?
Yeah, I'm not sure if you answered it already, but what was with the int in the parentheses?
So, it could be like this, and I don't know if that actually is legal. I think it is. Good. So, this is a function declaration. So technically, if in your header file, I'm not putting a header file here, but just to make it simple, I could do this.
And then in your CPP action,
Give them a name, correct. So this is legal C code. I'm just compiling it just to show you. I didn't write it out here because in general, since it's a function pointer, you don't know what the actual function you're calling is going to call it, so you don't want to give it a name. That would confuse the reader. So here, I just left it as it is. But yeah, I think that's what confuses people. They don't realize that's the function parameters.
Oh, so in main, it just takes, you don't need to like have an end next to.
No, because remember this print, or let's go down here. Remember your namespace. This variable called print is actually a legitimate identifier, is actually the official term, and it points to this up here, which is the identifier for a function called print. All your functions are actually variables / identifiers, however you want to think about it. You just you just so rarely do it this way, you never think of it this way. But yeah, they're just identifiers, just like a standard local variable might be, like val is inside of each function. They're just identifiers. Their type happens to be function as opposed to integer, double, et cetera, et cetera, et cetera. How are we doing? Any other questions? Because this does trip students up. And I gave you the 5-minute, explanation. All right. This is actually very powerful. Before I move on, bless you. This function pointer is actually how Linux implements their device drivers. Or when you want to implement a device driver in Linux, they give you a table of functions to implement. Like if someone calls read or write on your device driver, you have to provide a read and write function. The way they do it is they give you a structure with all the pointers, and you just fill in those function pointers with your function that you've written, and you're done. So this is actually widely used. Also, whenever you do OOP, this is what's happening under the hood. They just don't show you this, by the way. But this is actually what's happening when you do some type of, when you have inheritance, and it has to figure out which function you're calling. It's done via function pointers. By the way, in case I haven't told you already, there are always pointers, pretty much always, in every language. So unless your program is incredibly small and written in assembly, or maybe Fortran, you have function pointers. There's no way around it. You just don't, the language just hides that from you. All right, I think that's it for function pointers. Great. So let's do their summary real quick so we can finish up. Binary tree is either empty or a special node called a root node that has two nodes, either that are also empty or basically a root node as well, another tree. A node is a binary tree. It's called a leaf if it has no left or right children. Hey, everyone take a guess. What if a tree had 3 nodes? What would it be called? A ternary tree. And if it had 4, what would it be called? Quad tree, which are actually used. Quad trees are used a lot, as well as the 8 one, which is called an oct tree. Anyone want to take a guess on what those are used for? What's that?
That sounds disgusting.
Oh, it is beautiful, actually. Who has not taken this course before? Quad trees and oct trees are used a ton in games for collision detection. Well, actually, I think we get to quad trees in this class. Yeah, we'll get to quad trees.
Wait, how do you do collision detection?
Because you have your map, right? And if you put them in quads, then that's divided like this, so you have 4 quadrants. So if you want to find something, you just figure out which quadrant it is. And so when you look for something, it jumps to the quad, jumps to the quad, jumps to the quad, jumps to the quad. Therefore, trying to find something is a log-based for algorithm, as opposed to searching all the objects in space. So it's a far more efficient method for searching for objects. And also, due to how it's laid out, there are some algorithms to rearrange it as the object moves. So 4 is in 2D space, oct is just extended to 3D. But that's down the line. We're not doing that today. A node U is called a parent of V if there's a branch from U to V. Great. A leaf is basically a node at the end where it has nothing. Oh, no, that's a level, sorry. Level is the number of branches on the path from the root to the node. Level of the root is 0. The level of the children of root is 1. Great. The height of a binary tree is the number of nodes in the longest path. So the highest level plus 1, essentially. Hey, in order traversal, traverse the left. Then when you pop back, visit the node. Then traverse right. Pre-order is first visit the node, then go left, then go right. And post is go left, go right. And when you pop from the right, there's nowhere else to go, visit the node. Binary search tree, which is our first tree that was basically useful for what we're doing, because a plain old binary tree is not that much more helpful than a linked list. Really, it's not at all any more helpful. It just makes the code more complicated. But in a binary search tree, the root node is larger than everything on the left and smaller than or less than everything on the right. And that's done so your search will be hopefully log of n in average and worst case. All right, we're done. Any questions on binary search tree or function pointers before we go to the lab? Nope. Great.